Oh,
Yeah, we've heard that.
darn it. Good morning, attendees. We will start in about 1 minute. So we're just going to let a few more people join. All right. All right. I'm Lori Honigford, and welcome to our webinar. I'm the managing director of IAGI and today's webinar coordinator. Today's webinar is entitled Improving Geosynthetic Installations, and we have some fantastic presenters for you today. Our presenters are Brian Fraser, Vice President of Layfield Geosynthetics, Gus Fauci, General Manager at Demtech, Evan Bayo, QC QA Manager of Kamenko, and Todd Harmon, President of Hallaton and President of IAGI. So Brian will start off our presentation today. Brian?
Well, thank you, Lori. It's a pleasure to be here today, and obviously a real pleasure for me to be presenting with my associate board members, Todd, Gus, and Evan. So today we're going to start off with a quick overview and history of IAGI. We're going to be discussing the importance of professional installations, including discussing IAGI's guidelines and best practices. Gus is going to cover a section on good versus bad installation techniques. And Evan's going to discuss IAGI's Certified Welding Technician Program, CWT, as well as IAGI's Approved Installation Contractors, AIC program. We're going to be discussing and the importance of specifying IAGI in critical containment applications. And we'll wrap up today with a message from Todd Harmon, IAGI's president, just telling us some of the strategic directions and key things happening within IAGI. We will, at the end of this presentation, have a Q&A session. So we do ask that you use the Q&A button. And at the end of the presentation, Lori will read off the questions that you've submitted. So let's get started. So we'll just kind of start off with a day in the life of a geosynthetic geomembrane installer. The photo on the left is a field crew of Kamenkos deploying a second layer of HDP liner for a mining project in Nevada. And it certainly looks like utilizing all the proper deployment practices. The photo on the right is actually a fairly large 43 million square foot high strength geotextile project that is being installed by the Layfield Group on a tailings pond in Alberta, Canada. So the IAGI was founded in 1995, so we're just over 30 years of age as an association. And the International Association of Geosynthetic Installers represents geosynthetic material installers globally. And our founding members had a deep commitment to protecting the environment. And that commitment is still being followed closely today. So our mission at IAGI is to provide a forum for geosynthetic installers to advance installation and construction techniques and to strengthen the knowledge and communication within the geosynthetic industry. IAGI promotes the important pillars for installers of safety, quality, productivity, and industry best practices. So it's a pleasure for me to introduce our board, our current board at IAGI. And starting at the top left is Todd Harmon from Hallaton, and Todd is the president of IAGI. To his right is Philip Denis, and Philip is with PRD Geo Consulting based in Canada. And to his right, third from the top, is Nikki Harojo, and Nikki is with SIGSA in Panama. And the top right is Eric Lamartine, and Eric is with Green Earth Environmental, based in Saskatchewan, Canada. I'm on the bottom left, Brian Fraser, and I represent Layfield, USA, Canada, and Australia. And to my right is Gus Fossey, and Gus is the general manager for Demtech based in the US. And to his right is Evan Bale, and Evan is the QA QC manager with Camanco. And finally, the bottom right is Marco Horojo, and he's with SAI Mexico. And actually, when I look at this group of eight, we actually have over 200 years of geomembrane installation experience. So it is a really good group that's leading the board here at IAGI. Really experienced. So IAGI started as a North American focus group and today provides installation support and services globally. And an example of that is the photo on the right. This is actually one of our IAGI members, CIM Holdings in Africa. So this was a project they did in 2025, an installation of a mine tailing pond in Western Africa. So today, IAGI represents hundreds of installers, and we have many of the top geosynthetic installers around the world. We're in 23 countries and we touch 6 continents. And our members include geosynthetic installers, CQA service companies, consulting engineers, manufacturers, fabricators, and equipment suppliers. And the photo on the right is Demo Dave from DMS Welding Equipment and in one of I believe actually one of our plants, and he was showing us how to pre-qualify his new welder. So a little bit of on Demo Dave. He's been in the lining industry for over 40 years. He actually started with Columbine on equipment manufacturing, many years with Demtech, and now with his own company, DMS Equipment. So Demo Dave certainly is a geomembrane equipment expert. And Dave has a long history with IAGI, and we really want to thank him for his past and ongoing contribution. So in terms of geosynthetic products, our membership touches all of the materials. We're every day working with HDP lining materials, LLDP, linear low density polyethylene, geosynthetic clay liners, GeoNet and geocomposite drainage products, a variety of flexible geomembranes, whether reinforced or non-reinforced, and as well as geotextiles, non-woven cushion fabrics, and high-strength geotextiles being installed by IAGI geosynthetic members. We also participate in all the main environmental containment markets. So we're involved with municipal solid waste and landfill liners and closure systems, hazardous waste landfills and hazardous waste treatment facilities. In oil and gas, we're involved with upstream, midstream, and downstream operations. In mining, you'll find us around the world in key mining markets and where they're mining for metals and minerals. In municipal water applications, we're active in water storage, potable water storage, and wastewater treatment. In agriculture, you'll see us with waste lagoons to anaerobic digesters to irrigation canal liners. And as well, we are installing recreation and decorative ponds and things such as golf courses, etc. And kind of a catch-all, civil engineering and construction. So we're actually lining complicated tunnel systems to putting in commercial vapor barriers, dealing with radon and moisture, etc. in foundations. So we are installing lining systems with earth and concrete ponds and reservoirs. We're in above ground storage tanks. We're doing work with soil covers and closure systems, anaerobic digesters, underground concrete clear wells, and floating cover systems. And kind of the photos show most of those applications. So we're going to talk about best practice manual. So over the past few years, IAGI has worked to create a best practices for installation of geosynthetics, and a number of those are on our website. But we're really pleased to announce our first manual for municipal solid waste MSW applications, and it's available now free to all IAGI members. And that new manual is called Installation of Geosynthetics in MSW Applications. So we've released 12 of the 15 chapters currently now available. You can contact IAGI, and excellent manual written over a couple years with input from prominent installers and stakeholders around the world. So first chapter starts off with an introduction to geosynthetic construction in municipal waste applications. We talk about pre-construction meetings, the importance of submittals, geosynthetic storage and delivery requirements, materials and testing, subgrade construction and approval, geomembrane deployment, as well as geomembrane seaming and tie-ins, and geomembrane repairs. And chapter 10 is on soil and aggregate cover replacement. And the last two current chapters are geosynthetic clay liners and GeoNet and geocomposites. And again, we'll be publishing the remaining three chapters in the very near future. And those are currently available free to all IAGI members. Also want to talk about our existing guidelines, installation guidelines available from our website. So these include guidelines for proper installation of HDP and LLDP and a variety of flexible geomembrane materials. And we kind of categorize by different weights and types of flexible materials. So these installation guidelines were developed for geosynthetic installers as well as CQA service contractors and consulting engineers designing containment systems requiring geomembranes and geocomposites. The flexible geomembrane component was built in conjunction with the FGI, now known as the Flexible Geomembrane Institute. And I will note that IAGI strives to work very closely with industry associations to improve technology and education. So we work very closely with the Flexible Geomembrane Institute, known as the FGI, as well as the Geosynthetic Institute, the GSI, and the International Geosynthetic Society, IGS. So again, these installation guidelines are available on our new website, iagi.org. And if you basically go over to the right, you'll see on our main website landing page a resource and publication section. Click on that, and then you can scroll down through the various installation guidelines, starting with, for instance, HDP or LLDP, and going through the guidelines of the various weights of flexible geomembrane materials. So I'm going to turn this over to Gus to talk about geomembrane welding.
Welcome, everyone. Thanks for joining us. Thank you, Brian and Evan, for putting all this together. I know it's a lot of work. You guys did a great job. Todd Harmon for our president, thank you. And of course, Lori and Paige. I'm going to be talking about good versus bad installation procedures directly related to the plastic welding. I'm going to start out directly to wedge welding. Temperature, speed, pressure, excessive overlap, not enough overlap, contamination, subgrade conditions. With extrusion welding, welding too fast, welding too slow, overgrinding, undergrinding, improper welding rod, and machine positioning. These are problematic. This is stuff that can be problematic during welding installation. Next slide, please. With wedge welding, excessive temperature and pressure example. So this is directly related to welding. I'm going to start with some demonstrations of these pictures that show too much heat and too much pressure. These are examples. Starting on the left, obviously this is too much pressure and too much heat, squeezing out all the plastic on the outside, compromising the weld. The next picture to the right is too much pressure, too much heat, and or too slow, which leads to a burnout and improper welding practices. The next picture to the right shows too much heat, too much pressure, and I'm guessing too much overlap on the top sheet, which pushes the top sheet over, which compromises your weld, which results in low shear numbers, peel, bad welding practices. And on the last picture on the right is a straight burnout. Obviously, it's too much time to load the machine, too much pressure, too much heat leads to a burnout and costly repairs. Next slide, please. So wedge welding, not enough pressure and not enough temperature and or too fast. So this is the exact opposite. On the picture on the left illustrates welding too fast, not enough penetration, not enough indentations of the nip rollers. You can see that it's not a good weld. And other pictures on the right, 1, 2, and 3 is examples of failures. You have low shear numbers, excessive peel, not enough penetration, partial peel, and full peel. So the effect is low shear numbers, failed destructs, failed trial welds, and excessive peel, and obviously costly repairs, which Evan will be talking about in his part of it. Next slide, please. So extrusion welding, tacking, too much heat or not enough heat. So this picture here demonstrates too much heat when you're tacking your liner together. You have excessive wrinkles and very bad grinding techniques. The grinding's not all the way to the edge, too many valleys and crevices to get the proper grinding when you're doing your extrusion. It's very problematic, and which will lead to obviously uh, too many humps and valleys to grind properly and failed trial welds and failed destructs, of course. Next slide, please. So extrusion welding, over grinding and under grinding. This is very important when you're prepping your liner to do your extrusion welding. And this is directly related to plastic welding with extrusion welder. On the left here, you can see the grind marks showing. This is way excessive. It's way outside of your weld, you're centered on your seam. It's way excessive. And if you look at the very end of that picture, you can see they straightened it out, which looks proper. And the second picture from the left on the right shows an illustration of the grind mark showing after the weld, improper welding position with the extruder, which is too much extradite on the liner, and or all of the above. The next picture on the right is just erratic grinding, erratic welding, too fast, too slow. It's exaggerated, I get that, but this is what you do not want to see in the field. The third picture, or the fourth picture on the right is prep for grinding and getting ready to do your extrusion weld. The grinding marks are 3/4 of an inch on each side of the seam, nice and centered. That's what you're looking for proper grinding. The effect is low shear numbers, failed destructs, failed trial welds, excessive peel. Next slide, please. Extrusion welding, common causes of failures in the field. Of course, dirty liner is no good. Water and moisture, plastic welding does not like water, does not like moisture. Improper welding rod, make sure you have the proper welding rod for the material you're installing. Damaged or modified welding tip or welding shoe, it's very important. Improper positioning of the extruder is also very important. Not staying centered on the seam is also very important. Proper grinding disc and worn out grinding discs are very problematic. And also don't forget to make sure that your preheat blower that is on and at the proper temperature according to what thickness of material that you're welding in the field. Next slide, please. Examples of good and bad welding technique and positioning. So there's a few pictures here illustrating proper and improper welding techniques. On the very left-hand side there, you can see a nice, clean, straight weld, no grinding marks showing, centered on the seam. That's what we're looking for a proper weld or a trial weld. The next picture there just demonstrates proper welding position. The technician is in good stance. He has the machine centered on the seam, proper grinding techniques. That's proper right there. And then on the right is improper welding positioning. Of course, that's the same picture. Too much welding rod on the plastic, tons of grind marks showing. Not good welding practices. You get crystallization, way too much welding rod. That's not good. And then the last picture on the right, of course, is erratic grinding and erratic welding. Next slide, please.
Okay, well, thank you.
Back to
Thank
you,
you.
Brian. Sorry. Thank you.
Yeah, no, thank you, Gus. And so talk a little bit about the cost of bad installations. And unfortunately, from time to time, our industry still does encounter some problem projects and failures. This is often the result of multiple factors. It can be problems with the containment design. It can be problems with incorrect material selection and chemical resistance. It can be problems with site preparation and subgrade construction, as well as just poor installation quality, whether welding or installation damages that have happened during operations. So this can result in leakage or liner failure, causing a lot of risk, whether ecological or environmental, and certainly financial damages and liabilities to the owners and potentially all parties involved. So on the bottom left, we just show some examples of failures from a large whale issue that we see, and these whales are normally caused by organic gases underneath the liner systems without the proper drainage composite systems to remove the gases. Or sometimes if we have really significant leakage, we'll get ballooning from fluids building up under our liner system where we don't have proper leak detection and monitoring systems, etc. The photo on the top left here, probably an example of most likely a brittle, possibly a ductile failure along the seam. Next to that, as Gus mentioned, photo of too much heat, too much pressure. And then the photo to the right is an example of environmental stress cracking, something we normally see with the higher density, higher crystallinity type materials, HDP as an example. And the photo on the left we took from a job site where somebody forgot this is a T-seam and kind of really poor workmanship and not properly capped. This would be a major leaking point. And the photo on the right was an industry photo of really poor mechanical anchorage. And of course, we'd have lots of potential leakage at that point. So in terms of quality workmanship, really IAGI mentions that experience really shows. And IAGI places a very high priority on quality installation and workmanship. So just kind of looking at three photos of properly installed pipe boots and where, we are ensuring we have proper welding and clamping and testing. So normally the best practices wherever possible are to work with prefabricated pipe boot components, ensure proper welding of the flange and the sleeve area, proper mechanical anchoring hardware and processes. And testing, we need to make sure that we're testing both visually and with vacuum box testing and electrical spark testing. Also, mechanical anchorage we see on a lot of containment systems. So really important here that we are as well using proper clamping, proper anchoring, and proper sealing to create, in many cases, a watertight connection below the fluid level, and as well as where we are supporting or anchoring the geomembrane system above the water level. So with mechanical anchorage, we're normally using stainless steel batten bars, neoprene or EPDM gaskets, stainless steel bolts, and we need to ensure we're using everything from proper torquing pressures, etc. And as well, we also in new concrete applications will often put in polymer or plastic embedment strips that we weld to. So photo on the left, this is a ring berm of a tank farm inside the tank berm, and we're doing the mechanical anchorage there. Photo in the middle, this is actually a concrete partitioning off a pond, and they're mechanically anchoring on the top to just support and anchor the material, as we obviously don't have an anchor trench. And the photo on the right is a challenging application. This is under the water level potentially. So it's actually a sprayed applied polymer on the wall and a 40 mil HDP on the liner system using a special transition strip that's welded to the liner and then mechanically attached at 3-inch centers to the transition strip to the spray applied wall to again make a watertight seam. as well as really important with the geomembrane deployment and welding techniques. So we have to follow proper procedures of pre-qualifying our welders, what we call trial seams, ensuring we're using proper welding techniques, whether wedge or extrusion welding, proper CQA practices where we are testing both destructive and non-destructive from the liner installer's perspective, as well as ensuring we're always following safety and good work safe practices. So at that point, I'm going to turn this over to Evan to talk about our CWT program.
Absolutely. All right, thank you, Gus and Brian, for the great intro so far in the webinar. As Brian just said, my name is Evan Bao. Good morning. I'm serving my second term on the IAGI board, and over the next couple of slides, I'm going to try to answer some of the questions that Gus and Brian brought up just now. How do we avoid some of these bad welding practices that we see out there, or maybe more importantly, just on some of these critical containment projects, how do we ensure we get that right kind of installation company or right kind of installation technicians out there to do this really important work for us? And so I'm going to start with, our CWT, the Certified Welding Technicians program that IAGI has. And so the next slide, please, Brian. The Certified Welding Technicians program, first of all, it recognizes the knowledge, experience, and skill of installation welders, both in HDP, LLDP, PVC, and reinforced geomembrane welding. A lot of other industries, welding industries specifically, have largely recognized welding certifications through institutions like the AWS, whether it's for welding pipe or for structural welding. And really, there's no reason that geosynthetics shouldn't have the same thing. And that's really where the IAGI CWT program comes into play. And it's really was created to recognize and provide accreditation to a lot of these field welding technicians who have really spent the time and effort, in the crazy environments that we work in, to developing their skills, developing their experience, and it's a way to recognize them, right, and provide them some accreditation just throughout the industry. And so the next slide, please. The program itself, there's kind of two parts. There's the day of proctored exam, which Gus is going to touch on a little bit after myself. But there's usually a proctored exam, a third-party oversight, which is typically done by a CQA company, a supplier manufacturer like Demtech or Leicester, or an engineering firm. But before all the testing even happens, there's a lot of prereqs that needs to be submitted to IAGI and reviewed. And some of that's listed on here, right? So 90,000 square meters or 1,000,000 square feet of installed for polyethylene or PVC geomembranes, or 50,000 square meters or 500,000 square feet for reinforced geomembranes. And this has to be across 5+ different jobs, and it has to be provided with a government issued identification card. And so one thing I really want to highlight on here that's really important to myself is those 5+ different jobs is really important because it shows that these technicians who are being looked into being certified as CWT, that they've been on multiple projects, they're able to adapt to potentially different material types, different thicknesses, certainly different ambient conditions, and it keeps it from being a technician who's just been on one very large project with the same conditions, the same setup every day on the wedge or the gun, and just welding the same thing day after day. And the CWT program itself, it has to be renewed every 5 years. And so there's a certification, the initial one, and then there's a updated renewal test every 5 years as well. And so the day of testing, that's on the next slide, please. What does it look like? There's a written exam, of course, with a proctor watching everyone taking the test, ensuring that everyone's putting in their own answers. And it really tests comprehensive knowledge about welding practices. It ensures the people getting the CWT certification, they're not just guys who, have the wedge set up for them every morning and just throw it into the seam and start running it. These are guys who understand how pressure, heat, temperature, speed, all of it affects the welds. It makes sure they understand what air testing does, what vacuum box testing does, and how all of it relates to making a good installation. The test itself is available in English, Spanish, French, Indonesian, Portuguese, and Chinese currently. I'm sure, if there's languages that need to be out there, we are more than happy to accommodate. And then there's been a lot of recent updates that Gus is going to talk through as well, but we're starting to allow the exam to be taken online, and this has allowed results to be provided much quicker after completion. And the second half of the test, it's a hands-on welding test where the technicians perform welds depending on material under proctor supervision. So obviously this would be fusion and extrusion for the polyethylene or hot air for PVC. The weld samples themselves are sent to a GAI or LAP third-party laboratory such as TRI. And the results are graded and then sent back to IAGI, and we grade them to industry standards of GRI for the polyethylene or reinforced, which is GM19 or GM19B, or FGI 1126 for the PVC. And so they're really graded to industry standards. It's not something that IAGI's just created. It's something that the industry widely accepts. And the welders themselves, they have to pass 100% of the seams submitted. And so, as an example for polyethylene, this would be 8 different types of welds for each technician with 5 samples on each one, so 40 different tests. And this would be, for different thicknesses, different, smoother texture material, HC versus LL, the gun and the wedge. And so it's a lot of tests that need to be submitted, and 100% of them must pass to receive the certification. And so the next slide, Brian. All this to say, each year IAGI tests over 250 candidates. And between the written and the field testing, it's not a walk in the park. Take it from someone, yours truly, who actually did fail his first extrusion test CWT. It's not easy. It's not just handed out to anyone who walks off the street. As you can see on the slide, 83% passing rate. So that means 17% of the candidates fail on their first attempt. And you have to remember, these are candidates, who companies have already identified as some of their best welding techs. They've already met the prerequisites. So they're not just new techs off the street being submitted to this program. They are usually very experienced techs, and they're still not, a full grade. It's not a 100% passing rate. And so this really goes to show it's a real certification for exemplary welding technicians who really deserve the recognition for the work that they do. We work on extremely important critical containment projects. We work on extremely important, protecting the groundwater, protecting the environment. And it's a way to recognize these guys who have really put in the skill and the effort and time into doing this. And for liner installers like Comanco, it also really is a way for us to kind of reward and provide a huge sense of accomplishment for a lot of our welding techs in the field. It's a way that they can kind of differentiate themselves from the industry, or in the industry from their peers. It's a way to show that they're just an outstanding welder in their field. And so I'm going to pass it off to Gus to talk through the role of proctors.
All right, thank you. Welcome back. Thank you, Evan, for your professional insight. And yes, the CWT program is our sole purpose of IAGI, is to make sure that the technicians that take this test and to get an actual card that says they are CWT certified is very important, and it's a very difficult test. And we make sure that the technicians that do the testing, before they get their card that says they're CWT certified, we make sure that yes, they are professional. Yes, they are doing about proper welding techniques. So I'm going to talk about the role of IAGI proctors, which is a very important part of the CWT process, to coordinate and administer the CWT testing process. I'm going to start with number 1. Prior to administering the test, to streamline the certified welding technician CWT testing process, IAGI proctors will take the following steps in advance of testing. So number 1, coordinate with the customer, request and collect all required documentation, including candidates' resumes, which Evan talked about, candidate names, candidates' photo IDs, direct them to the IAGI website for their study guide so they can study for the test. And coming soon will be the online testing to replace the written test. Number 2, submit documentation to IAGI corporate. Ensure all required documentation is submitted to Paige and Lori at IAGI corporate prior to the test date to help streamline the process when possible. We can work with the customers on that. Number 3, confirm test type with the customer. Verify which certification test candidates will be taking. There are several of them. There's high density polyethylene, linear low density polyethylene, there's reinforced materials, there's PVC, and or all of the above. It's very important to verify with the customer which tests they're taking. Number 4, confirm proper materials needed for testing. Ensure all materials are correctly specified according to the test type being administered. Reinforced material, PVC, polyethylene, and all different reinforced materials will require specifications from the manufacturer as required by the testing laboratories. And number 5, provide material sourcing context. If the customer needs assistance obtaining the proper materials, provide recommended suppliers. Refer customer to the IAGI website for approved material sources. Coming soon to the IAGI website. You can always reach out to Layfield Plastics with Brian Frazier, Demtech, and there's many other sources for sourcing the proper materials if the customer does not have them. So this is the role of the proctors. Next slide, please. New proctor and refresher training. So we're going to talk about proctors. New proctor training. IAGI is reaching out to the industry professionals to recruit new proctors worldwide to increase the availability of CWT programs. Proctor refresher training. Who's in and who's out. In order to maintain your CWT proctor status, IAGI will require a refresher training on new procedures. Coordinate with IAGI headquarters. It's very important. We have a lot of good stuff going on with IAGI now. We're changing up stuff with the online. We're making a lot of changes. So any proctors out there, we will be reaching out to you to get you a refresher training, and any new proctors, reach out to IAGI. We'll get you trained up and get you certified to be a proctor worldwide. Coming soon, proctors will be trained on the new online CWT testing process to replace the in-person written test or the written test. Proctors will reach out to preferred testing labs to communicate the expected timelines for sample results. It's very important to follow the process if you're a proctor. It's very important to follow through and make a few phone calls to make sure it goes through good. Keep in touch with the IAGI corporate page and Lori throughout the entire process. Next slide. This is IAGI in action. There's just a few pictures here just showing a good weld on the left there. The candidates on the bottom left. You can see the attendees taking their CWT test. It's very important that you keep the candidates separated, at least one seat in between them. There's no talking, there's no cheating, and the proctor needs to be present during the entire process. And of course, make sure that all the samples meet the specifications that are submitted to the third-party laboratories. And the rest are just a few pictures of us in action. And if you're interested in becoming a proctor, reach out to IAGI. We'll have it on the website so you can reach out to IAGI, and we'll give you the proper procedures to become a proctor. And you'll take the test. We'll give you all the information needed. And I'm going to pass this back now to Brian. And thank you, Evan, for your professional insight.
Yeah, actually, we're going to go over to Evan, and he's going to talk about the Approved Installation Contractor Program. Thank you, Gus.
Yeah, thank you, Gus, for wrapping up the CWT program. Naturally, for IAGI, once the CWT program was up and running, kind of the next logical step was for us to find a way to recognize not just the welding technicians, but the companies who are doing things the right way. And that's really where the AIC program, the Approved Installation Contractor Program, came to life. And so what is it? On the next slide, the AIC program was developed based on the principles and business practices that an industry advisory board determined were important to geomembrane installation companies who consistently perform quality and safe installations. And obviously the goal of this was to continue to promote companies who are consistently performing work on these high leverage, high liability projects. And a secondary intent was to reduce the amount of due diligence needed from owners or engineers when selecting geomembrane installers. Unfortunately, I think we're all too familiar with companies who will maybe lowball a bid and they cut corners during the installation process. And this ultimately leads to a lot of rework and additional costs, but really it's poor stewardship of the projects and environment that we're all kind of called to protect. And that's kind of why we're all in this industry. And so the next slide. Our AIC program, again, like I said, aims to promote industry growth and provide better quality workmanship on our projects. And the program recognizes geosynthetic installation companies that meet a minimum level of professionalism, ethics, and business practices. And so there's a big review process, but they must meet requirements, and we'll talk about it in the next slide. But just in some of these areas of corporate history and business practices, insurance verification, safety training, professional competence, and experience. And so on the next slide here, we've got long list. These are just some of the key elements. It's not all the elements that are reviewed and submitted, but company history information about each company, a minimum of 5 million square feet installed annually by the company, the ability to be bonded, proof of general liability, workers' comp, and automobile liability insurance, proof of having a safety training program that involves a drug-free workplace, a health and safety orientation program to bring on new employees. At least 15% of the crews must hold CWT or must be certified welding technicians. And the 2 letters of recommendation, each dated within the previous year, from engineers or GCs or owners that the companies that the installation contractors have worked with, or geosynthetic manufacturers such as Solmax, Agro, Scaps as well, who have worked closely with these geosynthetic installation companies. And again, this is not all of it, and I want to really emphasize this information. It's not reviewed by myself. It's not like IAGI, Paige and Lori don't review it. It's sent off to a third-party accounting firm, and they review and verify the information prior to providing us information for certification. And it's a pretty long list of requirements that not every liner contractor is able to complete, and it certainly requires a lot of time and resources on the liner contractor themselves to gather this information and submit it. And on the next slide, ultimately, really, it comes down to, why choose IAGI, CWTs, or AICs for your projects out there. The really low-hanging fruit that I kind of touched on is we've already done a lot of the due diligence for you. We've looked into the recommendations of these companies. We've confirmed their bonding ability. We've reviewed their safety programs to ensure they're up to industry standards. But really, the biggest reason, I mean, personally, and hopefully for a lot of us here, is that the work we perform in our industry is incredibly important work, right? Protecting the groundwater and the environment with geosynthetics, it shouldn't be left to just anyone who can buy an extrusion gun or a wedge and start welding out of their pickup truck. A lot of these projects that we work on carry a lot of liability, and they should be left in the hands of contractors who have the experience with these projects. Contractors, who won't leave you or leave the project with a bunch of safety violations with OSHA or MSHA coming to your site. The ones who will install material correctly the first time, like Gus showed and Brian showed in some of the earlier slides. Ones who won't leave the owners or engineers having to, look for repair crews soon after the installation ends. You won't have to deal with warranty claims, hopefully, or litigation. And really, it's technicians and companies who know how to adapt and be ready for whatever a difficult project throws at them. I think we're all pretty familiar that nothing ever goes smoothly on a geosynthetic installation site. And so it's having the right companies who are out there who are ready to adapt and ready to perform all the work, still with safety, quality, experience in mind as they go through. And so on this last slide here, what could this look like for specifying IAGI on your projects or recommending having IAGI on your projects? These are a couple of examples that have been used on previous specification for projects. The first one, obviously, geomembrane installer shall have current AIC status issued by IAGI. This could also look like the geomembrane installer should employ a certain percentage of CWT welding technicians on your site. However, if AIC or IAGI isn't something you're able to specify that specifically, I think it's still really important to have other requirements that can ensure the work goes to contractors who are ready to perform it. This can look like some of these other examples here of the installer shall have a minimum number of square feet or square meters of successful geomembrane installation experience in the past couple of years. The geomembrane installer shall document the ability to provide a performance and payment bond of a certain monetary amount. The geomembrane installer shall carry insurance coverage in the following minimum limits. And again, really, it ultimately all comes down to just stewardship of the environment and the projects that we've been provided, right? I think we all want to have the right contractors, the right welding technicians on your projects who again will leave your site or who will take your site, care for it with good hands, and pass it back to you without any safety issues, without any quality issues. You can just end your project kind of being able to sleep well at night. And so, yeah, I'm wrapping up the AIC and CWT programs. I'm going to pass it back to Brian, and he's going to go through, wrap up this webinar with a couple of the other things IAGI's been working on.
Yeah, no, thank you, Evan. And I just want to echo the AIC and CWT programs are very strong, very stringent, and ensure quality workmanship on critical environmental containment projects. So well, I just want to touch base with some of the interesting things we've been doing on LinkedIn. So about 10 months ago, IAGI started a new IAGI LinkedIn page. And yeah, we've been populating that with a lot of good content. So visit us on LinkedIn. Example on the left, each month we put out a member spotlight project using an interesting, challenging spotlight project. One on the left was a leachate containment system, I believe done by Kamenko in Florida. The middle photo, this actually was a really good article on really best practices and different methodology of constructing geomembrane T-seams. As well as the photo on the right was one of our early articles on introducing the smarter geomembrane welders with data acquisition, just so moving towards smarter welding, leading to more stringent capabilities from a CQA perspective. We've published a lot of really good articles over the last 10 months. The most recent one, Geomembrane CQC from the installer's perspective versus CQA from independent third-party testing companies. We have an article on critical versus non-critical containment, where we look at single and double and even triple line systems as we move into more hazardous waste applications. And raising the standards of geomembrane welding and the importance of the CWT program. As mentioned, a really well-visited article on constructing geomembrane T-seams. We did an article on minimum geomembrane leakage versus zero leakage and the role of action leak rates. And from the engineer's perspective, the important questions when selecting a geomembrane, there's many materials and thousands of different chemicals. So how do you select the right material for the right application? And HDPE versus LLDP geomembranes, and which is better in specific applications? And as mentioned, smarter geomembrane welders with data acquisition. And we published 5 or 6 geosynthetic installer safety articles, which are always important. So in addition to that, we are currently have a IAGI subcommittee, and we're working on 3 guidelines, and we hope in the next few months to circulate and upload to our website guidelining on IAGI practices for air pressure testing, vacuum box testing, and constructing of T-seams. Just again, a major emphasis on quality control, both CQC and CQA is a big pillar and strategic importance for IAGI. So a lot of articles and discussions on destructive versus non-destructive testing, proper procedures for vacuum box, air channel, air lance testing, electrical leak detection, and really trying to define the role of CQC from the installer's perspective and independent third-party CQA. Just want to just show again, it's just some great workmanship being done in the industry. A photo on the left was a complicated landfill closure system, lots of different geometry and steep slopes, and that was performed by Hallerton Environmental. And the photo on the right, one of our profile series, that was Atlantic Lining Industries, Elko in New York State, another landfill closure system. And this actually also incorporated the AGRU or watershed geo closure turf system. So I'm going to turn this over to Todd, IAGI's president, for a discussion from what's happening at the high levels of IAGI.
Hey, thank you, Brian, Evan, and Gus, and everyone else that have joined us today. Gentlemen, thank you. That was a great presentation, a lot of information there. There are a lot of great things happening at IAGI, as you've just heard. It's a very exciting time for an association that was started over 30 years ago with a board that was made up of installers working together. We have pushed to meet the needs of our industry's future with support from a board with a lot of geosynthetic experience, ensuring high standards of quality, safety, and productivity. IAGI is not just installers, though. We have members from great design engineers, CQA companies, owners, manufacturers, equipment suppliers, all working together to take our industry with geosynthetics to another level. New initiatives. IAGI has a new website, a new CRM for data storage, and pushing out all the new information. The best practices manual, as Brian just mentioned, is used by installers and everyone involved on the geosynthetic site. More training videos and some new installation guidelines. We're working on IAGI chapter expansions to support global growth. Right now, we currently have, there are 3 new chapters that we're in the process of initiating. There have been requests from members that want to get involved, and we're responding. Go ahead, next. Our first chapter is going to be the Australasia chapter, covering Australia, New Zealand, and the Oceania region. Nick Morris of GeoQ will be the new chapter director. Nick has a lot of experience on the installation side, working in the trenches. Now he's overseeing the quality control side of the projects in the region and is a perfect fit for IAGI's first chapter. The rest of the board's not final, but it looks like it'll be Nick Morris of GeoQ, Alex Gersh of Layfield, Graham Brown of FabTech, Warren Hornsey from TRI Australia, and Jonathan Shamrock from Tonkin and Taylor, and myself as a guest member from the Home Office as a director. The other areas that we're considering for new chapters are Africa and Latin America. If there's a similar demand for a new chapter, we'll do what we can to make it happen. Next. Get ready for the 4th Geo Games in Quebec, Canada. The games are occurring during the 13th ICG International Conference on Geosynthetics. There are a lot of teams signed up and some new requirements for the games. If you've missed the advertisements, go to IAGI's LinkedIn page and watch them. They're brilliant. A special shout out to our main sponsor for the games, Agro, for their continued support. And also thank you to the rest of the sponsors for their support. And if you want to still be a sponsor, you can still sign up for the fun and get noticed. Next. We're having a special webinar for the Spanish-speaking areas covering the same details that we have today. The webinar date is May 27th, covering the best practices being used today for installations, good versus bad installations, welding, pipe penetrations, mechanical anchoring. We'll be talking a lot about the IAGI CWTs and AIC certifications that you just heard about. Please come join us. Next. Here's a shot of a well-orchestrated installation from Layfield Crews. This is a 400,000 square foot, 6-layer triple-lined HDPE liner, 2 layers of geocomposite, and a heavy geotextile cushion layer. It's an oil and gas produced water pond. This is what IAGI installers do well. We work on the difficult, hard jobs that really need their professionals working on them. Our environment depends on it. Next. This is Australia's largest geomembrane line brine pond in the southern hemisphere. It's a 10.8 million square feet of HDPE liner, GCL, and geocomposite. This pond utilized IAGI's CWTs for the installation and IAGI's AIC for the qualification for the installer. These certifications help to keep the wannabe installers, I love that one, I use this one a lot, that may have put in a goldfish pond before. They're not qualified. We're striving to work on specifications wherever we can to make sure IAGI trained crews and installers are showing why it is important, minimizing leaks and costly callbacks. In fact, Nick Morris and GeoQ perform their services on this project. Thanks. Next. Now I want you to meet the backbone of the organization, Laurie and Paige. Laurie has been with IAGI since its inception. Laurie has a tremendous amount of experience writing geotechnical articles and putting together some really nice case histories on past projects. I think she can hold her own with technical details that any engineer in our industry might throw at her. Paige Richards is not new to the geosynthetic arena either. I remember her when she was working at Geosynthetics magazine in the 90s. Paige has taken over coordinating the CWT and AIC programs. And any installer that has had a CWT test performed lately, thank Paige for the speed and precision. Thanks to both of you. Picture on the right is us in Denver. You see Gus on the left, me, Paige, Laurie, Marco, Brian, and Nikki. Missing are Evan, Phil, and Eric. Thank you. Back to you, Laurie.
Okay, well, thank you. That was fantastic, Todd. Really great to see all the great things happening in the strategic direction at IAGI. We really have the ship sailing very well right now. So I think at this point we're coming to the end, and I think we're going to ask Laurie to read off any questions.
We do have some questions. The first one is going to Gus. There was a question regarding grinding. So is there a limit for the grinding, a distance after the extrusion that it can be visible? You're muted, Gus.
That's a good question. Thank you, Laurie. With the grinding marks showing after the weld, I believe technically you're allowed 1/8 of an inch to 1/4 of an inch that is allowed to be showing, but it's very controversial. In my eyes, in my training and all the stuff I've done with IAGI and proctoring, I recommend no grind marks showing at all. 3/4 of an inch on each side of the seam, covering the entire grinding with extradite to prevent low shear numbers. Because if you have grind marks showing and you do a shear test, then you're going to get a low number on your shear test because you never know how thick that liner is on the very edge of the seam. Hope that answers your question.
All right, thank you. Thank you. The next question is, what is the cost of certifying a welder from Colombia or Panama? Seems maybe the cost will be difficult to be paid. I'll take that question because I work with the CWT quite a bit. The costs really vary based upon what type of welding you're doing, what exam you're taking. So I encourage you to go to the IAGI.org website and pull down the proctor booklets for the material types you're interested in. And listed in the proctor booklet is all the exam costs. And the reason it varies is, for example, in the polyethylene testing, you can test just HDPE liner or just LLDPE liner. You can test for extrusion and wedge. And so if, for example, you're in a part of the world where you don't use much LL, you may not want to spend the money to go test for it, so you can get certified just on HD. And so much of the cost for the CWT is driven by the cost of testing the samples. As Gus referred to in his discussion, there's quite a few samples that go in and are tested by our test labs. And that drives so much of the cost. Now, the second half of that is you need a proctor. And depending upon what type of arrangement you can negotiate, you can use somebody local. If there's not anybody available local, we can certainly train a proctor. I do encourage you to pick somebody who has a familiarity with with the geomembrane industry, and that's just, it helps really facilitate the whole system. Otherwise, if you fly in a proctor, they generally charge a day rate plus their travel expenses. And if you have further questions, by all means, send an email to Paige or I, and we'll be glad to get you more specific information. The next question I've got is, greetings from Brazil. Are there geomembranes specifically designed for landfills? Are there new studies about that topic? So I guess maybe Evan or Todd would, or even Brian, which one of you wants to take that one?
Well, I'll say
Yeah.
that you do need to follow your regional regulatory requirements. Normally, your equivalent to the EPA will have regulatory requirements to what type of material that is being used, both from municipal or hazardous waste landfills, and both from the geomembrane portion to the closure system. So normally we find in most parts of the world that the geomembrane in waste management is normally HDP with a specific thickness measured. I'm assuming in metric parts of the world, 1.5 or 2 millimeter. And caps and closure systems are normally looking for more flexible materials, higher elongation. So linear low density polyethylenes, PVCs are commonly used in that application. So that would be my 2 cents on that. Check with your.
Also, I was going to say, send us a note. There are a lot of CWTs and proctors in Brazil, working real closely with them, and we can get you in touch with the right contacts to get some more information from there.
Any more, Lori?
Yes, I think we have time for one last question. The question is, when specifying IAGI CWT on projects, what is the minimum quantity of CWT personnel required to be recognized as meeting proper CWT involvement? This assumes that not all welding techs on a project will have a CWT. Todd, you want to run with that one? Or maybe Evan?
Evan,
Yeah,
I'll take it.
absolutely.
Go ahead.
I'll run with that.
All right.
There's not like a great minimum quantity. I think personally, you don't expect every person on the crew. You don't expect, laborers, the operators to have it. But I think as far as personnel, 20% seems like a good minimum requirement to me. Um, that way, on a pretty standard crew of 10, you've got two guys who are qualified as CWT technicians.
Right.
Yeah, yeah, absolutely. You're absolutely right. The question, not all welding techs on a project will have CWT, but having some out there who can kind of be the master seamers or oversee a lot of the welding is certainly a good requirement.
And to be honest with you, we use it as a tech in training. So you start to learn how to hot air seam, you learn how to grind, you do everything else. When you're able to take that test, that's a way we can promote you. So everybody wants to take that test, and that's only reserved for those that have shown they're ready for it. And then, so I would want anybody running a wedge or an extruder on our crews to have CWT, actually operating the equipment.
Absolutely.
Well, thank you. And I think we're getting to the point of our top of the hour, and our time is wrapping up here. So I wanted to thank everyone who attended today and registered. We'll be making sure a copy of this recorded webinar is available for all companies that registered. Really want to thank Lori and Paige for all of their behind the scenes support work, helping to administer and coordinate this webinar. A lot of energy went into it. And certainly want to thank Todd and Gus and Evan for doing a great job participating. So again, a lot of great things happening at IAGI. You can see our contact information below at iagi.org. IAGI at IAGI.org. Please visit us and consider joining us. Again, we've got a great membership and a lot of momentum, and want to thank everybody for their time today.
Yeah. Yeah. Thank you very much.
All right.